All right, this is Unit 2, Lesson 1, Vertex form of a quadratic function. Our essential question is, how does the equation of a quadratic function in vertex form highlight key features of the function's graph? Okay, and here is our table of contents. Representations of quadratic functions. Okay. A function is a quadratic function if its equation can be written in the form f of x equals ax squared plus bx plus c. So it's got that square element to it with a where a cannot be 0. All quadratic functions are transformations of the parent function defined by f of x equals x squared. So again, it's a parabola. The graph of a quadratic function is called a parabola. So it's a U-shaped function. The vertex of a quadratic function is f of x equals a times x minus h squared plus k, where h, k is the vertex of the parabola. Vertex form is useful because it highlights the vertex of the graph of the quadratic equation, as well as the axis of symmetry. So transforming a quadratic function. How are transformations of the graph of f of x equals x squared related to an equation representing another quadratic function? So vertex form shows 3 different ways that a graph can be transformed. The value of a, which is the number that's outside the parentheses, determines the direction the parabola opens and whether the graph is stretched or shrunk. Okay. The value of h determines the horizontal translation, so left, right. And the value of k determines the vertical translation, so up or down. So if I have g of x equals negative 1/2 x plus 2 squared, okay, the equation shows that the graph is to be translated 2 units to the left. It will open downwards because it's a negative, and it will be vertically compressed. Okay, so again, we start with our parent function. We're going to move that function 2 units to the left. And then we're going to vertically compress that function and flip it over the x-axis. So again, when a is greater than 0, the parabola opens upward. When a is less than 0, the parabola opens downward. When the absolute value of a is greater than 1, the graph is stretched. And when it's between 0 and 1, the graph is compressed. Okay. So again, the value of a determines that direction and whether it's stretched or compressed. And then h and k are my vertex, but they're also my horizontal and then vertical translation. Determine key features of a quadratic function. So what are the key features of the quadratic function f of x equals 3 times x minus 4 squared plus 5? Okay, so again, I can have 3 different ways that the graph can be transformed. So I'm looking at the 3, the 4, and the 5. So in this case, I start with my original equation. The 3 determines that the parabola opens upward and is vertically stretched. The 4 tells me that I move 4 units right. And the 5 tells me that I move 5 units up. Okay. So what are the key features of the quadratic function? Okay, so again, I'm showing this transformation. So I started with x squared. I moved it 4 units to the right. And then I vertically compressed that because it's 3. Okay, and then I moved it up 5 units. Okay, so you're still following order of operations when you're creating these functions. Okay. So what are the key features of the quadratic function? So my axis of symmetry, or my mirror image, is going to be when x equals h, or in this case, x equals 4. Okay, so again, it's that when that fold is along the, if I were to fold the equation, I would get a mirror image on both sides. Okay. The vertex, of course, is the ordered pair HK, in this case 4, 5. So the K component of the equation also tells you about the range because it gives you either a maximum or a minimum value. In this case, a minimum. So the range is y is greater than or equal to 5, my K value. Write an equation of a parabola. So what is the equation of a quadratic function with vertex -3, 5 and a y-intercept of -2? So step 1 is to substitute the values of my vertex in for my values for h and k. Okay, notice I have a -3 for my h, which means when I rewrite this equation of x minus -3, I'm putting that -3 in there. It's going to become a +3. Okay. Then I'm going to substitute the values of x and y from the y-intercept and then solve for a. So I was told the y-intercept is at -2, which means if it's a y-intercept, it's crossing the x-axis at 0. So that's where I get the 0, -2 from. Okay, so I substitute those values in for f of x and for x. Okay, and then I'm going to simplify this equation. Okay, so I substituted in my values for f of x, x, h, and k, and I'm solving for a. So when I do this, I've got +3. So 3 squared gives me 9. So I have -2 equals 9a plus 5. I subtract 5 from both sides. -2 minus 5 is -7 equals 9a. I divide both sides by 9. So I get a equals -7/9. I substitute values of a and h and k into the equation. Okay, so I get my final equation of f of x equals -7/9 x plus 3 squared plus 5. Write an equation of a parabola given the graph. So example, the height of a kicked ball is a quadratic function of the time it has been in the air. Okay, so the graph of the quadratic function is the parabolic path of the ball. The vertex of the graph is 4, 6 in this case, and the path of the ball includes the point 0, 2, probably from the point where the ball was kicked. What is the expression that defines this function? I want to write the quadratic equation in the vertex form, so the form that we've been using, as well as the form y equals ax squared plus bx plus c. So I'm going to use the information that I was given. So I was given an x and a y at 0, 2, and I was also given the vertex, so hk at 4, 6. I substitute those values in, so I get the equation 2 equals a times 0 minus 4 squared plus 6. 0 minus 4 is -4. -4 squared, or -4 times -4, gives me 16. Okay, I subtract 6 from both sides, so I get 2 minus 6, which is -4, equals 16a. I divide both sides by 16, so I get -4 over 16, which simplifies to -1/4. I substitute the value for a back into my equation. Okay, now I have vertex form because I have my a, my h, and my k. From there, I want to go to standard form, which is the ax squared plus bx plus c. So all I'm going to do is I'm going to take that and I'm going to factor it out, essentially. So I'm going to FOIL it. So x minus 4 squared is like saying x minus 4 times x minus 4. I do x times x, which gives me the x squared. X times -4 and -4 times x give me that -8x, because I get -4x minus 4x, which combines together to get me -8x. And then -4 times -4 gives me that +16. Okay. I then substitute that value back in. So instead of x minus 4 squared, I put in the x squared minus 8x plus 16. Okay. And I still have that -1/4 out in front. So I'm going to distribute that -1/4 to each of the things that are inside my parentheses. So -1/4 times x squared is -1/4 x squared. -1/4 times -8 is +2 when I simplify it. And -1/4 times 16 is -4. Okay. Now I've got that. I can combine my like terms. So -4 plus 6 gives me a +2. So in standard form, y equals ax squared plus bx plus c. I get f of x equals negative 1/4 x squared plus 2x plus 2. Write an equation of a transformed function. The function g is a translation of the parent function f, 4 units left and 6 units down. Write the quadratic equation in vertex form and in the form f of x equals ax squared plus bx plus c. Okay, so my parent function, again, my vertex, I start at 0, 0, and my general parent function for a parabolic equation is x squared. Okay. They gave me the vertex by telling me that they moved 4 units left and 6 units down. And I can also see on my graph that it looks like it crosses at the point 0, 2. Okay, so I'm going to use that point as well as my text to figure out what my value for A could be. So I substitute the values of 0, 2 and negative 4, 6 into my vertex form. So I get 2 equals A times 0 plus 4 squared minus 6. I simplify my equation as much as possible. So 4 squared gives me 16. I add 6 to both sides, and I get negative 8 equals 16A. Dividing both sides by 16, I get negative 8 over 16, or negative 1/2. So I substitute that value back into my vertex equation. So I get f of x equals negative 1/2 times the quantity x plus 4 squared minus 6. Okay. They also asked me to put this in standard form. So I went ahead and did x plus 4 times x plus 4, which gave me x squared plus 8x plus 16. Okay. And then I'm going to distribute that negative 1/2 to everything inside. So I get negative 1/2 x squared plus 4x minus 2 in the end. So negative 1/2 x squared minus 4x minus 2. In conclusion, the graph of a quadratic function is called a parabola. Vertex form, which is the form that we learned about specifically here, was f of x equals a times x minus h squared plus k. And I'm going to use this when I have a vertex and at least one other point on a graph. Okay. It doesn't have to be where it crosses the x or the y axis, but you can use that because usually it makes your life a little bit simpler. Okay. My vertex again is hk. My axis of symmetry is when x equals h. If a is greater than 0, the graph opens upward. It has a minimum when y equals k, and the range is k to infinity. Okay. If a is less than 0, my graph opens downward. It has a maximum at y equals k, and its range is negative infinity to k. And that is the end of lesson 1.